The problem that we are going to solve here is problem 32 from chapter 3. So problem 32, chapter 3 from Halliday 9th edition. Okay, so it's a problem about vectors. There is not much physics here. So what is the story? Let me get space. So the problem is the following. We have a certain vector that is given to us, and I'm going to draw it here. Is this vector A? All right. And they give us the magnitude of this vector A. This vector A is 17 meters. Very well. They also give us angles. And let's see angles for what? First, there is one frame that is illustrated there, and I'm going to draw it here, which is this frame here. This is the x-axis, and this is the y-axis. Always remember, frame is arbitrary. We choose them according to our, for convenience, okay? So according to this frame here, the angle between this vector A and the x-axis is 56 degrees. Okay? Given that, I can find the components. How? Well, I'm going to project this vector in the x direction. So this is going to be my AX component. And here is the projection in the y direction. This is my AY. So here we have a right triangle, 90 degrees. There you are, we have the two components. That's the usual way. So now we play with sines and cosines to find these components. The AX is touching that angle, is adjacent to that angle. So I know that AX is going to be A and then cosine of 56. So you just have to find the cosine of 56, multiply that by 17, and you're going to get this AX, which apparently is something like, I think, 9.51 meters. Okay, how about the AY? The AY is A. Now, AY is opposite to the angle. Opposite means sine, so A sine of 56. Put these things in your calculator and you get 14.1 meters. Very well. So we are done. But then the question continues. What would be the components according to another frame? Okay, and this is a nice thing because what is real here, what is really telling us about the physics of what is going on in this problem is that vector, the yellow vector. But the components, well, the components will depend on the frame that we choose. The other frame that they gave us is something, let's try to draw it here, is something like this. This is now my x direction, I'll call it x prime, and this is our y direction. And so what are the values of the components of my vector? But for this blue frame now, what else do they tell us? They say that this second coordinate system is inclined by an angle of 18 degrees with respect to the first one. In other words, they are saying that this angle here between this x and this x prime, this angle here is 18 degrees. Okay, very well. I'm going to draw this frame again separately. So otherwise it gets too confused here. There are too many things. So I'm going to write again our vector. This is our vector A, it's the same thing. And let me put this blue frame now here. Okay, so this is our blue frame, the x prime, and our y prime. So we want to find the components according to this frame. Okay, so what do we need to do? We have to find the components. So we have to draw our right triangle. Now we have to project this. So here we have our AX, but AX prime. And here we have our AY prime. These are the two vectors that compose this total vector A according to this frame. And they want to know what are the magnitudes of this AX prime and the magnitude of AY prime. So the procedure is going to be the same. All that we need to know now is what is this angle? And what do you think is this angle? Let's come back to that original picture that we had. This whole thing here, we said is 56, right? This angle between the two frames, 18. There we are. So what do you think is this angle here between our vector and the x prime? Well, this one is 56 minus 18, correct? 56 minus 18 is 38. Okay, so this is the angle. So now if we want to find the ax prime, that is going to be a, but now careful, cosine of 38. Yeah, and what is the ay prime? Well, a sine, but sine of 38. Okay, so you put that in your calculator and you will get the two numbers. And I think is here 13.4 meters in the x, and in the y direction 10.5 meters. So you see how important this is. The vector is the same, but the components change because frame is arbitrary. So we'll get different numbers for different frames.